The switching method is really a gift to you. It should not, it may look like it's a confusing at first, but you will soon realize how helpful this trick is. What do we mean by that? Well, when you assign priorities, you will have to go again from 1 to 2 to 3. But we may have a case where actually 1 is in the back, or 4, group 4, the lowest priority is not in the back. So in this case, if we assign priorities to this, you know the O is going to be the number 1. Then comparing between these two, you need to find the tiebreaker. So the C here is attached to 2 H's and the C. So that would be C, H, H. And this one is just simply attached to 3 H's. So this one would win. That would be 2, and this would be 3, and that would be 4. Now, if you have the mental capacity to visualize this, if I draw 1, 2 to 3 like this, I'm drawing it on the opposite side, meaning this, okay, you would have to be in the back of this molecule to see it, and it would be the reverse for us. So our eyes are really right here, and what we see in front of us is the H, the CH2, CH3, the ethyl, and of course the methyl. The OH is in the back. So if we draw it this way, we're drawing it actually in reverse to what's in the back. Think about it. I will show you models when we meet. So what we do is, just a quick rule here, is that anytime we have 4 not in the back, you have to make it in the back. You have to give it this hashed line. And there's a quick way of doing it. What you do is you switch the numbers between them. You can switch the atoms if you want, but switching the numbers should do the job. So I'm going to just say this is 4, and that's a 1. If you would like, you can switch the atoms, but it becomes too messy. So now look, I have 1, 2, and 3. 1, 2, and 3. Now what is that? That's what? R. But I made a switch. And that switch, just to help me draw it on my side, but I have to remember to take the opposite. So it is an S. So you switch, anytime you make a switch, you take the opposite of the configuration that you actually determined. So keep that in mind. Let's look at some examples in general. So you always want 4 in the back. If not, then you have to do the switching method. Otherwise, you may draw it like that way, but then you'd have to imagine it as if you were sitting in the back. You can do this with a family member. Their clockwise to you would be their counterclockwise to them. If you think about it. Okay, so let's talk about some examples. Let's work on these. Let's say we want to assign R and S for these. Okay, what would be the number 1? It would be this one right here, because we have an N. What would come next? The C or that C? Yep, the one on the top, because you have, this is a carboxylic, by the way. It's drawn like that. Remember the condensed formula. So you have 2 O's. Remember the double bond counts twice. And of course this one. And this one is just 3 H's. So that would be 2, and that would be 3. And of course H is in the back. H will always be 4 if you have it in the molecule. So it goes from 1 to 2 to 3. What is that? That's an R configuration. Okay, finally we see something, and sometimes the H is not shown. If it's not shown, it means it's in the back. But here is another one where we have a skeletal structure. You'll see this a lot. So let's assign this. So we go 1 for O, and then you know H is going to be 4. What is going to win? This group, the ethyl, or the methyl? Well, if you're still doubting, what you have, remember these are 3 H's. And you have a C right here. You have a C, but you have 2 H's and a C right there. So this is, again, a CHH. And this one is just HHH. So you'll see that the larger the group, as long as they're not substituted, they're going to win. So that's going to be 1, that's 2, and that's 3. Luckily 4 is not in the back, and we love it when it's not, when it is in the back. So we go 1, 2, and 3. That's also an R configuration. Now let's include this in the name. So if we were to name this, I'm going to redraw it. Okay, we don't have to include the H, but we are, just to be consistent. This would be 1, 2, 3, and 4. So that's a butanol. We have 2 butanol. We have 2. So what was the configuration? It was an R. So all you have to do is put this in parentheses before the name and the prefix, and that would be called R2-butanol. You might ask, well, what should we do if we have more chiral centers? Then you would actually have to number also the configuration. So it would be 2R, 3S, whatever it is, but we'll get to that later. This only applies the R to where the chiral center is at. So if you have no chiral centers, then you don't actually include the R. It would be just the name without the chiral center.